Alright, so the first thing I decided to work on was the kind of snow ice one, and then I also then proceeded to do where you take the cold water and then you put it in a glass container, then you put some ice. So right now what you're seeing is the second experiment. So I took two pictures. I took the water bottle that I used for that experiment, so I used a different one for both of them just because the first one there were some difficulties, didn't really go as planned. Neither did this one, but it did become better. So on the left you can see the water bottle. It's pretty frozen, but there is still a lot of liquid in it, so it was cold. I put them in at around 7:30, took them out at about 9:30 to 10, around 10. So it did have a lot of time in there. I know in the video that we watched, he did say 2 hours and 45 minutes. So I'm thinking that this could possibly be why it didn't turn out as well as the video. But so on the right you can see the actual results. So I just used a regular ice cube tray, you know, the little round kind of ones. I used a mason jar, which I usually use as like a cup. I just put some of the cold water. A lot of the water in the water bottle was blocked by ice. I got as much as I could, but a lot of it was still ice. So maybe I left it in too long, if anything. But it was kind of weird. So half of it was super cold and ice, and the other half was like water. So what I'm thinking also that I did see is my freezer is a little weird. There's different temperatures in it. The only reason I know is because I put 4 water bottles in there. I just kind of wanted to see if all of them would freeze the same, and 2 in the very right and back were extremely frozen. There's absolutely no water. It was frozen, and then the ones on the left were kind of frozen but still had water in them. So this probably could have messed up the experiment a little bit, but also gave me more insight to why. But so looking back at the picture in the mason jar, you can see that the ice cube doesn't really have anything around it, but there is like a little crystallized portion that kind of just is hanging out there. So it somewhat worked, but it did not work as well as the video because usually it's around the ice cube. So that was just kind of like a little part of the ice that kind of broke off, and I just kind of threw it in there and that crystallized. So what's weird is that the smaller portion did crystallize, but the larger ice cube didn't, which is a little weird. I would have thought it would have been the other way around. But this could probably be because the smaller one was able to freeze more and become more cold, as the bigger one needed more time to. That's just kind of my hypothesis on that, but it somewhat worked. I think next time I do this experiment, I definitely want to move the bottles around and experiment with it more, because I don't know if the water wasn't cold enough or if the ice cubes weren't cold enough. So I definitely want to go back and forth and leave the ice cubes in there longer, but they were in there for a while. They were just kind of ice cubes I had, so they're already there. But maybe if I just use smaller ones, if I crushed them up and used them, maybe that would work as well. Alright. And then this is the first one I did. So on the left is the drinking water. I just went to my local Smith's, which is like a pretty popular grocery store in Nevada. I live in Las Vegas. So I used purified drinking water to be exact. So this bottle was a little bit more watery than the other one. There wasn't as much ice. There wasn't really much ice being blocked or anything like that. It was still really cold, as you can see from the outside of the bottle, but it was still, it was different. It felt like it could have been colder, and I feel like if I left it in there longer, put it more to the right, I would have gotten different results. So basically what I did, I took this little container, I took the ice cubes I used for the other experiment as well, not those exact ice cubes, but just from the same tray, and I kind of stacked them in this little container that I used, and then I started pouring the ice, and in the video, it does show that it kind of crystallizes and it looks kind of like snowish, as a comparison, but as you can see, it did not happen. Nothing really happened besides just ice water. It seemed as though it was just kind of, if you were pouring water onto ice to drink, nothing really happens. Something I think went wrong was the water just wasn't cold enough. Like I said before, I did notice that there wasn't much ice, and the ice that was in there was very thin and fragile, and you can definitely just kind of like crunch it up back into the water. So another thing I did notice was that it didn't really crackle that much. Usually when I do pour cold water and ice, it kind of crackles or does something. I don't really do that. It just, there wasn't really much that happened, which was pretty disappointing. But I'm hoping that next time I do this, because I do want to do it again, I can figure out why. I do really think it's because of the water. The temperature of the water just wasn't cold enough, and maybe the ice cubes, but I'm leaning more towards the water just because of the difference between the water bottles, between the two I used for the two experiments. It was just a little weird. But yeah, that is the experiment. I really enjoyed it. I learned a lot, and I'm hoping to do it again.